In this problem, we have the integral from pi over 6 to pi over 3 of 3 secant to the fourth power theta d theta. Okay, so what we're going to do on this problem first is use the trig identity that says that secant squared theta is equal to tangent squared theta plus 1. And we're going to substitute out one of the secant squared thetas because, well, we can actually write that to show you what I'm talking about there. So pi over 6, pi over 3, this is the same thing as 3 times secant squared theta d theta. Okay, so one of these secant squared thetas we're going to substitute out with the tangent. The other one we're going to leave alone. So let's put the 3 out front. So 3 times the integral from pi over 6 to pi over 3. And we'll leave the first one alone, secant squared theta. And then the second one will change into tangent squared theta plus 1 d theta. Okay, now we're going to distribute. Okay, so that gets us 3 times the integral of pi over 6 pi over 3 of secant squared theta tangent squared theta plus secant squared theta d theta. Okay, and that's all part of the integral there. Okay, now we're going to split this up into two separate integrals, one of them being 3 times pi over 6 to pi over 3, the integral of secant squared theta tangent squared theta d theta plus 3 times the same integral from pi over 6 to pi over 3 of secant squared theta d theta. Okay, so we'll call this integral number 1 and integral number 2. Okay, integral number 2 is actually pretty easy, so I'm actually going to start with that one, the easier one first. So the antiderivative of secant squared theta is just tangent. Okay, so this one becomes 3 tangent theta from pi over 6 to pi over 3. Okay, and we plug in the limits. 3, put the parentheses, tangent of pi over 3 minus tangent of pi over 6. Okay, and tangent of pi over 3 is root 3, and tangent of pi over 6 is root 3 over 3. So this becomes 3 times root 3 minus root 3 over 3. Okay, we distribute that and we get 3 root 3 minus root 3 because the second one has a 3 in the denominator, so it cancels. Okay, so all in all that becomes 2 root 3s. You have 3 of them minus 1 of them. Okay, so 2 root 3. That's the easy one. Okay, for the other one, the secant squared theta tangent squared theta, we're going to have to use a u substitution. So here's integral number 1. We're back to that one. So we're going to use u substitution, and we're going to make u is equal to tangent theta, which means du is equal to secant squared theta, d theta, which means d theta, if we solve for that, move the secant over, is du over secant squared theta. That's the reason that it works, because we can see that we have a secant squared theta on bottom, and when we substitute for the d theta, the secant squared thetas are going to cancel out. Okay, so not too bad on that one. So we get, I'm going to leave my limits alone. For now, I'm going to substitute back in. So I'm going to leave my limits alone for now. So 3 times secant squared theta, and then we've substituted u here for tangent, so that's u squared times du over secant squared theta. Okay, those cancel. So we get 3 times the integral of u squared. Notice I'm still not writing limits because I'm going to switch back my variables in the end. Okay, so this becomes u cubed over 3. There's also the 3 that was out front, so plus c, and this becomes u cubed plus 3, or plus c. Okay, so we substitute back in the u is equal to tangent, and then we can use our original limits. So we get, this is all equal to tangent cubed theta from pi over 6 to pi over 3. Okay, and when we substitute those back in, we've already saw the values up here. We plugged in the same thing, except it's just going to be cubed. So we get tangent of pi over 3 cubed minus tangent of pi over 6 cubed. Okay, and like I said, we already found those values. So this is going to be root 3 cubed minus, and we could put the cube on the inside if we want. I'll do that in the next step, but for this one I'll leave them outside. Minus square root of 3 over 3 cubed. Now we can distribute this, and we can distribute this to the inside, so that becomes the square root of 27 minus the square root of 27 over 9, because I distributed here and here. Okay, and then of course the square root of 27 can be reduced. You can take a square root of 9 out and leave the 3 on the inside, so it becomes 3 root 3 minus 3 root 3 over 9. Oh, excuse me, that's not over 9, that's over 27. Sorry about that mistake there. 3 cubed is not 9, it's 27. Okay, so this is a 27, and this is a 27. Sorry about that. Okay, so not a 29, 27. Okay, so when we do that, we need to, well, first let's combine it with the other answer. So our total answer, our final answer, okay, our final answer will combine the answer we got up here, which is 2 root 3. So 2 root 3, and then we'll do this one, plus 3 root 3 minus 3 root 3 over 27. Of course, the 27 and the 3 will reduce and make it over 9. Okay, so that becomes, let's also, since this is going to have a denominator of 9, let's make these have a denominator of 9 so that we can combine those together. So in the next step, what would we need to make a denominator 9? We'll multiply top and bottom by 9. That becomes 18 root 3 over 9. Multiplying the top and bottom, put it over 1 if you want. And then this one would be, times 9 would be plus 27 root 3 over 9. And then this one is, of course, we reduced that. It's already got a 9 on bottom. So minus root 3 over 9. And when you combine those together, 18 plus 27 minus 1, you get equal to 44 root 3 over 9. And that's it.